So I hope slowly you're getting the hang of distance and displacement. So let's try another type of question for distance and displacement. So see, in this question we have calculate the distance and displacement in the following. So we're given a circle over here whose radius is 7 meters. Now there are 4 points marked A, B, C and D. So boy is basically starting from A. First he goes from A to B, then he goes from A to C, then from A to D, and then he goes from A to A by B, C, D. So A to B to C to D and back to A. So in all these 4 cases, we have to calculate distance and displacement. So let's begin. So part 1, the boy is going from A to B. So I'll just give the heading A to B. So see guys, you're starting over here and you're going over here. So the first thing I want to calculate is distance. Now see guys, what is distance? It is the length of the actual path taken. So see, he's walking along this line over here. So what is this line? It is basically boundary of the circle. So we have to calculate this length over here from A to B. So how exactly do we calculate this? See, we know the entire boundary of a circle is known as circumference. And what is the form of circumference? 2 pi r. So what is AB? See, here we're given this is 90 degrees. So because this is 90 degrees means this is a quadrant. So this is 1/4 of a circle. I repeat, because this angle is given to us as 90 degrees means this is 1/4 of a circle. So the length AB is nothing but 1/4 of the circumference of the circle. Is this clear? So A to B, distance is equal to 1/4 of the circumference. So it is 1/4 into what is circumference of a circle? 2 pi r. Is this clear? So let's plug in the values. 1/4 into 2 into, because radius is a multiple of 7, I'll take pi as 22/7 into 7. I repeat, 1/4, 2 pi r. 7, 7 cancel. 2 divided by 2, 1. 4 divided by 2, 2. 2 divided by 2, 1. 22 divided by 2, 11. So we get the answer as 11 meters. That means the distance traveled is 11 meters. So I'll write down over here, distance is equal to 11 meters. Now the tricky part, what is the displacement? So see guys, what is the initial point? This over here is the initial point. What is the final point? B. Now for displacement, we need straight line path. So join A and B by a straight line. Is this clear? So basically we're getting a right angle triangle over here, AOB. So I'll draw this triangle over here. So I'll give the heading displacement. So see guys, to calculate displacement, we basically, what is displacement? It is AB. So let me draw this triangle over here. So this point is A, then this point over here is O, then we have B, and this over here is my straight line. So see, what is OA and OB? Radius of the circle. So if this is 7, this will also be 7. So 7 and 7. And this is 90 degrees. So we'll apply Pythagoras and get the answer. So in triangle AOB, we have AB square is equal to AO square plus AO square plus BO square. And which property is this guys? Pythagoras. So do mention over here guys, Pythagoras theorem. Or you can just say Pythagoras property. Now let's plug in the values. So we have AB square, I want to find out, is equal to AO square, that is 7 square, plus BO square, that is 7 square. So AB square is 7 square is 49 plus 49, that is 98. So AB square is 98. Now what is AB? It is square root of 98. Now we have to simplify square root of 98. So we do the prime factorization of 98. 2 times 49, 7 times 7, 7 times 7, 1. So root 98 is nothing but root of 2 into 7 into 7. So pair of 7 comes out. So it comes out to be 7. 2 remains behind. 7 root 2 meters. I repeat, all I've done is I've just simplified this root over here. How do we simplify? Do the prime factorization. Pair of numbers come out. So because we have a pair of 7, it comes out 7 root 2 meters. So what is the displacement guys? It is 7 root 2 meters. So right over here, displacement is 7 root 2 meters. So this is how you calculate it. So I hope the concept is clear. I repeat, for displacement, we join the initial and final point. So we get a right angle triangle over here, 7, 7. So we calculate AB, 7 root 2 meters. And what is the direction? Along AB. So displacement is this, along AB. Is this clear? So first part is done. Now let's move on to the second part. So I'll just draw a line in between to avoid confusion. Now moving to the second part. Second part is from A to C. So first step is we're going to find the distance. So see guys, we are going from A to C. That means diametrically opposite points. So basically we are traveling half a circle. I repeat, we're going half a circle. See, this is 90. So this is also 90. This is also 90. So from A to C, the angle is 180 degrees. That means we're going half a circle. So from A to C, the length of the path is half a circle. That means half of length of circle 2 pi r. So 2 and 2 cancel. We get this as pi r. Plug in the values 22 by 7 into radius 7. So distance is 22 meters. As simple as that. I repeat guys, how did I come to know it is 180 degrees? See, if this is 90, this is also 90. So this whole angle is 180. 180 degrees means half of a complete angle. So half a circle. Hence half into 2 pi r. So we get 22 meters. So distance from A to C is 22 meters. Now what about displacement? See, this over here is the initial point. This over here is the final point. So displacement is basically this straight line over here. I repeat, what is displacement? Straight line between initial and final point. So this line over here. Now this is the radius. This is also the radius. So what is the length of this line? 7 plus 7, 14 meters. So see, displacement is easy. In this case, displacement is basically the diameter. I repeat guys, what is AC? It is the diameter. So displacement is equal to AO plus OC, that is 7 meters plus 7 meters, which is equal to 14 meters. And what is the direction? Along AC. So displacement in this case is very simple, 14 meters along AC. So I hope this much is clear. Let's go ahead. Moving on to part 3. So in part 3, the boy goes from A to D. So let's first calculate the distance. So see guys, you're starting from A, you go from A to B to C to D. Actually, they should mention over here how you're going to D. So you can say A to B to C to D. Here also you can say A to B to C. Right, so there should be no confusion. You're going like this or you're going like this. So see, you're going from A to B to C to D. So what is the length of the path you're traveling? You're traveling this entire path over here. So this is 1/4 of a circle, 1/4, 1/4. So basically you're covering 3/4 of a circle. So what is the length of this path? 3/4 the length of the circle. So distance is 3/4 of the length of the circle. That is 2 pi r. So 2 and 1. So 3 by 2 into pi r. 22 by 7 into radius 7. Cut, 1, 11. 3 into 11, 33 meters. So the distance traveled is 33 meters. Is this clear? Now let's talk about the displacement. So what is displacement? Join the initial and final points by a straight line. So see, I'll use a different color. This is the initial point. This is the final point. Join it by a straight line. So displacement is basically AD. Now if you look, this displacement and this displacement are exactly the same. I repeat, see here the displacement is the same as this displacement. See, this is 7 guys. So this is also 7. So again we have a right angle triangle. Two sides are 7. So we know this will be 7√2 meters. Nevertheless, I'll still draw it over here. So see guys, for displacement, so I'll write down displacement over here. So see guys, I'm going to copy this triangle over here. So we basically have triangle AOD. So I'll draw the triangle over here. So this is A, this is O, this is D. And my blue line over here is basically this line over here, joining A and D. Now, what are the lengths? AO and OD are 7 each. 7 meters, 7 meters. And this is 90. So see, this triangle and this triangle are exactly the same. So from here, if you calculate the value, you'll get this as 7√2 meters. I repeat, just apply Pythagoras guys. AD square is AO square plus OD square. So see, exact same right angle triangle. Two sides 7 and 7, two sides 7, 7. So hypotenuse is 7√2 meters. So from here we get displacement is 7√2 meters along, what is the line? AD. So along AD. So as you can see guys, the distance is different over here, right? But displacement is same like this over here. So I hope this much is clear. Now moving on to the last part, which is super simple. You start from point A and come back to point A. So see guys, first we'll calculate the distance. I'll do it here itself. Distance is equal to, we started from A, came back to A. So one whole circle, meaning 2 pi r. So 2 into pi into r, that is 44 meters. Is this clear? Next, displacement. So see guys, the initial point and the final point is the same. This is your starting point, this is your ending point. So when starting and ending point is the same, or initial and final point is the same, what is the displacement? 0. So displacement is 0 meters. Is this clear? So this is how you solve such type of circular questions. See guys, it's very simple. Whenever you're calculating distance along a circle, it is some part of the circumference. And whenever you're calculating displacement, it is a straight line. So first we went from A to B. Because this is 90 degrees, each of this is 1/4 of a circle. So this over here is 1/4 of a circle, hence 1/4 2 pi r. So we got the distance as 11 meters. What is displacement? Join the initial and final points by a straight line. So we get a right angle triangle over here. So displacement is 7√2 meters. Then we went from A to C. So distance is now half of a circle. So half into 2 pi r. What is displacement? This straight line over here. 7 plus 7, 14 meters. Next you went from A to D. You covered 3/4 of a circle. Hence 3/4 2 pi r. What is displacement? Shortest part between initial and final point. So this line. So again we get a right angle triangle. Solve it 7√2. And then finally from A back to A. So you completed one whole circle. So distance 2 pi r. Because initial and final point is the same, hence displacement is 0. So this is how you solve such type of questions.